Alright, so this is a video about binomial expansion using the Pascal's triangle and the combinations that it provides. And what we're going to look at here is how to expand this binomial, but this time you'll notice in front of the variable m there's a coefficient of 2. It's the same procedure and process as before, but there's just one tricky thing that I need to draw your attention to. Okay, the other tricky thing here is, notice how it's subtraction in the binomial, so it's 1 minus 2m. Just to make sure that we are applying the negative where it needs to go, I always like to start these problems out by writing a negative, or a plus a negative. Meaning I'm changing the subtraction to addition because the negative really applies to the negative 2m. So it applies to the term, it's not just sitting there. Because a lot of students would forget about that and then make 2m positive when really 2m is a negative term. So I always like doing plus a negative there. All right, and then we look at Pascal's triangle, which I've referenced in another video before. And again, you can find that readily online if you need to know what to do there. But the third row of Pascal's triangle reveals the coefficients in front are going to be 1, 3, 3, and 1. All right, and then from there, we expand the first term, which is 1. And it doesn't matter if it's a variable or if it's a constant. Whatever the first term is, that's the term we expand. And we start by the highest exponent going down, so we start from the top down. And for the second term, we start from the bottom and go up, as far as exponents go. So really, I'm going to write 1 to the third, then 1 squared, then 1 to the first, and then 1 to the 0th power. All right, so whatever the first term is, it doesn't matter if it's a variable or a constant, you have to make sure that first term you go 3, 2, 1, 0. All right, the second term is negative 2m. Remember, the negative's included with that term. So I'm going to write negative 2m to the 0th power, then negative 2m to the first, negative 2m squared, then negative 2m cubed. All right? And another cool thing about changing the sign to an addition problem is that I can then make these plus signs, because that always just makes it easy. And then the signs will change naturally when we multiply this out. So, I still have the 1. 1 cubed is 1. Negative 2m to the 0th power. Well, really, what that is anything to the 0th power is 1. Right, it all becomes 1. So 1 times 1 times 1 equals 1. Okay, that's easy enough. All right, the second term, we have a 3. 1 squared is 1. Then, here's where it gets interesting. The exponent on that term right there, negative 2 to the first, the exponent applies to the coefficient, the number in front, and the variable. So the exponent applies to the negative 2 and to the m. So what I write is negative 2 to the first power and m to the first power. Again, it doesn't make a big deal if it's to the first power because it really doesn't matter if it's the first power, but for the other terms, it will make a big difference, and we'll get there. So, negative 2 to the first power is still negative 2. And 3 times 1 is 3. 3 times negative 2 is negative 6m. Okay. So, that's going to give me negative 6m. All right, third term, 3 doesn't change. 1 to the first power is 1. So, remember, the exponent of 2 applies to both the coefficient, negative 2, and to the variable. So it's going to give me negative 2 squared m squared. All right? So when I get negative 2 squared, it actually changes it to a positive 4. So if you didn't do that correctly, you would have gotten negative 2, and that would have been wrong because negative 2 squared is positive 4. And 3 times 1 times 4 gives me positive 12m squared. All right, and then we have this one here. 1 doesn't change. 1 to the 0th power is 1 still, because anything to the 0th power is 1. And then the cube, or the third power, applies to both the negative 2 and the m. All right, and negative 2 cubed is going to give me negative 8. 1 times negative 8 will give me negative 8m cubed. And so my final answer is down here, 1 minus 6m plus 12m squared minus 8m cubed. All right, so whatever term is first, make sure that's the term that you start with the highest exponent, so 4, 3, 2, 1, 0. And then the negative 2m is the second term, so you start at the bottom 0 and go all the way up to 3. So that is how you expand a binomial with a coefficient in front of a variable, as well as how you deal with a subtraction binomial or a difference binomial.